Hello, welcome to Math 252, Calculus 2 here at Cañada College. My name is Lapuz. In this video, we will be doing checkpoint 3.12. This is coming from section 3.2, trigonometric integrals. They're asking us to evaluate the integral of tangent cubed of x times secant to the 7th of x. And so if we have this problem-solving strategy next to us and looking through it, the first option is asking if j, that's the power of the secant, if that's even, then we have a way to go. It's not, so let's take the next one. If k is odd, the power of the tangent is an odd number, then we have a plan. And so what we'll do is we'll take that plan. Option number 3 is very similar to what we're looking at. It says k is bigger than 3, bigger than or equal to 3, and j is equal to 0, but that's not our case. So let's stick with option number 2. So what we want to do is we want to take out a tangent and a secant away from both of these factors, and then plan to rewrite everything in terms of secant so that the derivative of secant is equal to secant times the tangent, and then that'll give us our u substitution. Okay, so let's do that. Let's rewrite this. So we have the integral of tangent x. Now we're going to take one of these three things out, so we have 2 left over, and then we'll rewrite here tangent x. And then we have 7 secants, so we'll take one of them out so that we just have secant to the 6th, and then put the other secant function here. And then now this tangent times secant is a derivative of secant. And if we can change everything here in terms of secant, then that's great. So we will use this relationship here. This is already a secant factor, and then now we have to take tangent squared and rewrite that in terms of secant. And that is this formula over here. Now, any even power of tangent can be written in this way. If this was tangent to the 4th, then that would be tangent squared, quantity squared, and so we'll just have to FOIL things out. But fortunately, it's just regular tangent, so we'll just use that formula. Therefore, we have the tangent is going to be a secant squared x minus 1, and that's that. And then we have secant to the 6th of x, and then we have the secant x tangent x dx that we're going to replace after we do a u substitution. In this case, we'll let u equal to secant of x, so that du is equal to secant of x tan of x dx, and then that's exactly what we're going to replace. All right, we'll move on. Change everything into u's. We have a u squared minus 1 in parentheses and u to the 6th, and then this whole secant x tan x dx will just become du. All right, now we have a fairly easy polynomial integral. After we multiply things out, it'll make things even easier. So we have u to the 8th minus u to the 6th du. We'll go ahead and integrate that. We have 1/9 u to the 9th. That's a 9. And then we'll have minus 1/7 u to the 7th. And we'll just change everything back to whatever it was supposed to be. So we have 1/9 and then secant to the 9th of x minus 1/7 secant to the 7th of x, and throw in the plus c, and we are all good. All right, I hope that helps. Good luck.